exponent rules. Whenever I multiply monomials, I have to pay attention to if my bases are alike or different. In this first example, x squared times x to the 6th power. We learned that x squared is equivalent to x times x, and x to the 6th power is equivalent to x times x times x times x times x times x. When we count, how many times are we multiplying x by itself? 1, 2, 3, 4, 5, 6, 7, 8. So this is equivalent to x to the 8th power. Our shortcut, our simple rule, when you are multiplying like bases, keep the base, add your exponent. Keep the base of x, and you would add your exponents. 2 plus 6 would give me x to the 8th power. Now, when I have unlike bases, 2x squared times 3x to the 4th. This would be, I have a coefficient of 2. 2 is really raised to the 1st power. In this example, 3 is raised to the 1st power as well. 2 and 3 are not alike. They are not alike base. So I would have to then multiply them. 2 times 3 is 6. Then I look at the variable x, x squared and x to the 4th. That is a like base. Keep the base, add your exponents. 2 plus 4. My final answer is 6x to the 6th power. And that's the way that example would work. Now we have to be really careful when I have a little bit more complicated. If I had 2 squared x squared times 3 squared x to the 4th. We did not cover this in class, I just want to go over it. 2 and 3 are not like bases. However, I am not allowed to multiply them until I evaluate them. 2 squared is equivalent to 4. X squared. 3 squared over here is equivalent to 9. Before I multiply my bases, I have to make sure if they are coefficients, they are brought down to the 1st power. And now I can do 4 times 9 is 36. Keep the base of x. 2 plus 4 is 6. And my final answer is 36, x to the 6th power. When I now look at a power raised to a power, this was the example I did in class today. X to the 5th y squared. This entire base here is cubed. It's raised to the 3rd power. If I go to expand it and I write this out, it is equivalent to x to the 5th y squared times x to the 5th y squared times x to the 5th y squared. Using the commutative rule of multiplication, I can move things around. X to the 5th times x to the 5th times x to the 5th. Keep the base of x, add my exponents, 5 plus 5 plus 5, I get x to the 15th power. Y squared times y squared times y squared, keep the base of y, add the 2 plus 2 plus 2, I get y to the 6th power. And this is my final answer. We made up a shortcut, which was a rule. Whenever I have a power to a power, I am allowed, same thing, to multiply the 2 exponents together. So, 5 times 3 gives me the 15. 2 times 3 is equivalent to 6. Let's try one more. If you're not sure, let's expand it out. xy squared, that entire base is cubed. When I expand this out, xy squared times xy squared times xy squared. Now let's take a look at the base of x. It's equivalent to x to the 1st in each one of these. So notice I put the little 1, it helps me. X to the 1st times x to the 1st times x to the 1st is x cubed. 1 plus 1 plus 1. Y squared times y squared times y squared. Keep the base, add your exponents. 2 plus 2 plus 2 is 6. This is my final answer. If I did not want to expand this out, and I wanted to apply my power to a power rule, remember, power to a power, we multiply our exponents. I definitely would, x is to the exponent of 1. Please write that in. 3 times 1 is x cubed. Y squared 3 times 2 is 6. Notice my final answer is the same. In this situation, I am using my power to power rule. Let's try one more. 2a cubed squared. Let's apply the power to a power rule. 2 really has the exponent of 1. So for now, please write that in. When I square that, that is equivalent. 1 times 2 is 2. This is equivalent to 2 squared. Now let's look at the base of a. A cubed, that entire quantity squared. 2 times 3 is 6. A to the 6th power. Now when my numbers are small, 2 squared I know is equivalent to 4. I would then evaluate that, and this would be my final answer. These are the rules for power to a power. In your module, you have it written algebraically, x, y to the nth power. Again, remember, x and y have an exponent of 1, and when I would distribute, that is equivalent to x to the n power times y to the n power. When in doubt, please look at my tip right here. When in doubt, please expand the terms. We will have more fun with this tomorrow.